Let's look at inverse matrices. The concept here is similar to what you have seen before with numbers. So let's talk basic concept. Take the number 15, and in order to make it equal to the number 1, which would make it an identity, you would multiply it by its reciprocal. So in the world of matrices, we have a matrix, whatever A is, 2 by 2, 3 by 3, whatever it might be. It will equal the number 1, which in matrix terms is the matrix 1, 0, 0, 1. When we multiply it, what we would call the reciprocal here is actually this matrix to the power of 1, which is what negative 1 is make something a reciprocal. So I'm going to call it A minus 1. So part of our job will be to find that and figure out how to get that inverse. So that's the second part of this. What is the inverse of 1, negative 3, negative 2, 4? All right, let's take a look at the formula to use, and I'm going to write a generic matrix in this way. We will take the top left number as A, and the top right number is B, bottom left is C, and bottom right is D. The position is vital, because the way that you get the matrix for this, or the way that you get the inverse of this, is you do 1 over the determinant of this. And the determinants, we'll go over that more deeply in a different section on determinants. Right now on the bottom of this, we would do A times D subtract C times B, or B times C, if you prefer going by alphabetical order. A times D minus B times C, and that is going to multiply to a variation of this. We take the A and the D and we switch them, and we take the C and the B and we make them opposites, meaning that whatever sign this is, you take the opposite. Whatever sign this is, you take the opposite. So C stays in place, but it becomes negative. And B stays in place, but it becomes negative. That's how you get the inverse. Let's apply that to this. 1, negative 2, negative 3, and 4. What we will do will be 1 over 1 times 4 is 4, minus, well, 3 times 2 is 6. Negative and negative cancels out, so this is a positive 6. So it's 4 minus 6, because it's minus whatever the result is. And so we know that'll be a negative 2. And then we are going to multiply that 1 over negative 2 to 4, 1, switching those, and making that sign different and that sign different. So let's make it negative 1/2 times 4, 2, 3, 1. That equals, well, 4 times 1/2, 4 over 2 is 2, but it's a negative 2. 3 times 1/2 is 3/2, and it's negative, or negative 1.5 if you prefer. 2 times that is negative 1, and 1 times it keeps it the same thing. That is the inverse of this one. Now we can check it by using this. If we take this one and we multiply it by the inverse, we should get 1, 0, 0, 1. So let's check by doing that. So I'm going to write the first matrix times this matrix does it equal 1, 0, 0, 1? Let's find out. We're multiplying a 2 by 2. All right, so this is a 2 by 2, and this is a 2 by 2. Because these two inside ones, the columns here and the rows here, because they're equal, we can multiply it. The result is also going to be a 2 by 2, the outside ones. So I'm going to set this up down here for figuring it out. So the tops, I'll use the top row for both of these. And for this one, I use the first column because we're in the first column. And for this one, the second column. So 1 times negative 2 is negative 2. And negative 2 times negative 3, 3 over 2, the 2's and the negative cancel, so that becomes plus 3. So 3 take away 2 is a 1. And then this one times this one, 1 times negative 1 is negative 1. And then negative 2 times negative half, that becomes positive, and it becomes plus 1. So this becomes a 0. Now this one times this one, negative 3 times negative 2 is 6. And then we're going to do 4 times negative 3 over 2. 2 goes into 4 twice. 2 times 3 is 6, but it's minus 6. 6 minus 6 is 0. And then we're going to do the negative 3, 4 for here, and then this column. So negative 3 times negative 1 is 3. And 4 times negative 1/2 becomes a negative, and 2 goes into 4 twice. So 3 take away 2 is 1. We get 1, 0, 0, 1, just like we're supposed to. That verifies that this is indeed the correct inverse for this matrix. Now, let's do it on the graphing calculator. Also on graphing calculator, because learning to do it with that tool is vital. You're going to be using it more and more, and in real life, most jobs, you'll be using the tools you have instead of doing everything by hand on paper. So go into here and let's enter it. Just practice entering it. All right. So I'm going to enter this one, and then I'm going to do the inverse for it and show you how. Okay, second function in matrix, and I don't have any in here now, so I'll go over to edit and choose the first one, and I'm going to tell it that it's a 2 by 2. And it gives me a place for those. So 1 is my first number, negative 2 is my next one, negative 3 is my next one, 4 is my last one. Now I'm going to do mode and clear is what usually gets me out of there easily. I'm going to do second matrix, and I'm going to press on this one and press enter to see that I really have it right and to make sure I don't have negatives wrong. I have done negatives wrong in class, and you've seen it. So I want to be careful not to. You know it's too easy and it hurts on tests. Okay, that is the one. Now, the way I do the inverse is I pull it up again, but I don't press enter yet. What I do is I raise it to the power of, well, raise it to the power of 1. Oh, wait a minute, it's to the negative 1. I need to go back and change it. Negative 1. So I raised it to the power of negative 1, and when I press enter, I get negative 2, negative 1, negative 1.5, and negative half. So I correctly have the inverse for that. And so you see on the calculator, you enter the matrix, then you pull it up and you raise it to the power of -1, and it will give you the inverse. This works on a TI-84 plus. It does not work on TI-83s. Doing -1 to an exponent to a matrix is an update for the 84. It's not. At least it has not worked on any of the 83s I've used. All right. So that first couple of parts here for about inverse matrices. Let's put that aside, and let's take a look at one where it's a little bit of a bigger problem. We won't do it by hand. This is one of the reasons we will do them. Let's call this 3, and let's make it a larger one. Let's make it a 3 by 3, but let's do something different. Okay. I'm going to give you 1, -1, 1, 0, -2, 1, -2, -3, 0. And this is going to be an equation to solve, or a system of equations, a different way than using an augmented matrix. So the way this is set up, 2, 2, 1/2. Okay. Well, this system of equations gives you these x, or the results with those, you want to know what x is, what y is, what z is, in order to get that. So these times x gives you that, these y's do that, these z's give you that. It's not quite that way, but it's an equation where what we have is something like 5 times x is equal to 10. Well, what you do is you divide by 5 on both sides. Well, dividing by this is the same as multiplying by the reciprocal. So instead of dividing by it, we're going to multiply by the reciprocal, or rather the inverse. So what we need to do is to bring this over here as the inverse. So we're going to have x, y, z is equal to this matrix. So we'll call this one A, and then here that means this one is A minus 1 times 2, 2, and 1/2. So what we need to do is figure out the inverse of this and then multiply it to that. Well, we'll do that on the calculator. Let's take the calculator and let's enter it. In my case, since I already have one in here, I could do an edit one, but you know what? This is also a good time to show everyone how to clear them. So I am clearing that, just clears the screen. But to get rid of a matrix so that you have more room, like if I had filled up all 10 matrices in here, I would want to get rid of some. So I'm going to press the second button and memory. Memory is down here right above entry and right above, it's on the plus sign, the second function. And it gives me lots of choices. Don't do them unless you know exactly where you're going and what you're doing. And because if you mess up something else, you're going to take away something else, you're going to hurt some other things that you might want to do later. What we want to do is go to number 2, memory management, and DEL for deleting something. Press 2, and you have these choices, and the only one we are using right now is matrices, so go to number 5. And it shows you all the matrices you have. I only have one right now, but if I had a bunch, I'd want to clear some up so I could put new matrices in. Well, I'm going to get rid of this one by pressing delete. Just press delete and it's done. And when I press clear, I'm back to here. So now, let's go back to here. Let's make a new matrix. I'll make this one A again. This is a 3 by 3. 3, 3. A 3 by 3, so it sets it up for me to enter 1, negative 1. Don't forget to use the negative sign, not the minus sign when you're putting in a negative number. 1, 0, whoops, and I almost put the wrong thing in. I put a decimal instead of 0, press the wrong thing. Now I've got it right. Negative 2 and 1, negative 2, negative 3, and 0. Okay, so that looks right there, but I'm going to go to second and matrix and 1, and I'm going to look at it and see, oh, it did error because I already had something on there. Second matrix, 1, enter. Okay, 1, negative 1, 1, 0, negative 2, 1, negative 2, negative 3, 0. Looks good. I'm going to pull it up again. I'm going to raise it to the power of negative 1. And that is my inverse matrix. I could write it in here, but right now I don't even need to. I just need to take that and multiply it to that. Oh, but then I need to put this in. So let's go back to the matrices, and let's put in a new matrix. Oh, man, it'll be my B matrix. And this is 3 rows by 1 column. 3 by 1. What a smart calculator. It only gives me those tons that I need to fill in. 2, 2, and 0.5. 2, 2, and 0.5, or 1/2. So now I'm going to do second and matrix. Let's make sure that really looks right. Again, I have to clear what's in there. Make sure something else that's making it more complicated. Here it is, 2, 2, and 1/2. Now I'm going to do A minus 1 times, in this case this is now B. Second function, A, raised to the power of negative 1. Use the arrow key to get to the main arrow again. I'm going to put times, second function matrix, and 2. So now I'm telling it the inverse of A times B. Press enter, and it gives me the answer, x, y, z, equals 0.5, negative 0.5, and 1. Okay, so that tells me x is that, y is that, and z is that. And we should be writing it in this form, coordinate point form. And that would be the solution. So, this is what you want to recognize to do. You know how to enter matrices. You now know how to find the inverse. You find that inverse and you multiply it times another matrix because the 3 columns match the 3 rows, so we can multiply it. Calculator would tell you you couldn't. And you get this and recognize you can do x, y, and z. So what we looked at here in matrices, inverse matrices, was how to find the inverse by hand of a 2 by 2, and how you could check it and verify that it was an inverse, and then how to use it in an equation to solve x, y, and z if you were given one, even if it was a larger inverse, such as that 3 by 3.